There we go. And of course, just because we're seeing that it's recording doesn't mean it's recording from the right channel. So the best way to check it is to check my mixer control, and you can see it's recording from the right channel. This is on a per application basis, which means I can actually see which application is using what as an output and what using what as an input, which is really great. I can change one without affecting all the other applications. So we're set for this part here. So we'll go ahead and get the class started. And what I'll do is I'll start with a homework assignment that you should not know how to do it yet, unless you have watched the videos from previous semesters. And some people do. I mean, some people actually do that too. The homework assignment is called assignment statements, and that will be the focus of today's lecture. Okay, so today we'll actually get started with the actual pseudocode and also how to trace a program.
Did you enable the homework assignment?
Sorry?
Did you enable homework assignment? Like last night you forgot to enable it so we can't see it?
You can see it now. I think you can see it as soon as you complete the syllabus acknowledgement. You should be able to see this homework assignment. You can see the format of the procedure is about the same. You right click, you download the file, you work on one sheet. In this case, has the algorithm. The other sheet has the trace where you'll be working on. Same criteria, as the previous homework assignment. You got to make sure that your name is the author of the document. You also have to make sure that you use either LibreOffice or OpenOffice to edit the document. Of the previous homework assignment, of the 37, 38, people who turned it in, I would say 35 out of the whole thing got it right. Everything is just, everything is correct. They have the author name in the properties. The track changes remain to be on, and I can actually see the name of the author in track changes. So good job getting that part done. A few people turn in files that are not a document, so I could not give any points to those people who turn in a file that is not a document. I cannot see it as a document. And a few people, and I can see it too, a few people turn in and I look at the track changes. The first two changes were without a name, and then the last change has a name. So I think some people went on and at the third item, they remember, I have to remember to put my name, into LibreOffice, and I can see it on the third line, of the change, which is okay. I gave full credit to those people as well, not a problem, because in the end they remember.
So we have to put our name each time we start up LibreOffice?
Sorry?
We have to enter our name each time we start up
It depends on which computer you are using. If you're using the computers in room 152, yes, the answer is yes. You do have to make sure that you do the same thing every single time.
Personal computer?
On your personal computer, once you change the setting, once you set it, it should remember it, and you should not have to do it again. It's always good to double check. If you just, as you're editing the file, go to File Properties and check whether your name is the name of the last editing author. If you use portable Office, portable LibreOffice, that should be the same as well. Once you save it, it should be the same. All right. So let's take a look at this particular homework assignment. I always use right-click and use a save link as, just so that I know the file is placed, to whatever folder I choose to place it, and also, by the time it's saved, it is editable. If you click it, depending on the browser, sometimes it opens it, in read-only mode, and then you have to do a save as and do all the other stuff to get it to work. And I'm gonna do, I will not do recovery. And this is the homework assignment. So the homework assignment starts with sheet 1, and in class I usually magnify the spreadsheet sufficiently so the people in the back can easily read the content of the spreadsheet. This is the algorithm, okay? This is the algorithm that you're going to trace. We will talk about what an assignment statement is, what is a sequence, and stuff like that today. So you may or may not know how to do it just yet. People with some programming background can probably do it right now, But people who do not have any programming background, which is what this class is for, well, just have to pay more attention today. And that's partially why I talk about a homework assignment that you guys don't know how to do yet, at the beginning, so that you know why you need to pay attention today, or what to pay attention to. Sheet 2 is what I call a trace. So this is where you can show me that you understand how the algorithm works on a line-by-line, step-by-step basis. This is the only class where you'll be doing traces. In all your other programming classes, cisp300 and on, there won't be any traces anymore. Okay, which is a good thing because doing traces by hand can be tedious, but it's also kind of not a good thing because without requiring you to trace your programs, a lot of times people just kind of resort to, well, I'm too lazy. I don't want to read the algorithm and analyze and figure out what it's going to do. So what am I going to do? I'm going to run it. I'll let the computer run the program and let me know what the program is supposed to do. That's not necessarily the best way to analyze a program, especially when it's a program that you write and it has a problem, has a bug in it. Okay, so this class will focus on doing everything by hand, just so that you know how a program is supposed to work. Okay, so I'll leave this one open, just so that we can refer back to it when we need to, and then we'll go ahead and start today's lecture. Now today's lecture is kind of interesting because this link has always been here: variables, expressions, and sequences. It's some notes that I wrote some time ago. It talks about what we need to talk about today. But I also rewrote some of that stuff into these 3 documents here. In other words, the first 3 documents and this particular document, they are pretty much equivalent. They talk about the same thing. It's just that the way I talk about it is a little bit different. So you can choose which one to read. I recommend reading both, okay, just so that you have an alternative exposure to the same topics. So you might see me doing this kind of thing, from time to time, when I feel that what I wrote already is kind of dated, and I could put it already in a better way. Then sometimes I will rewrite something. All right, so let's go ahead and start with this slide here. And I kind of know that we have not really quite finished the discussion of algorithms. But I think we should get started with this one first, and then kind of go back to that discussion a little bit earlier. All right, so you can see that this talks about what is a variable in programming. So let me just magnify this a little bit. That's actually already. Drop it back one level. Okay, so the question is, what is a variable in programming? Now, in this class, we start with variables because the most basic type of statement in programming is called an assignment statement. And the effect of an assignment statement is to change a variable. And as a result, we have to talk about variables first. A variable has certain things. I mean, for one thing, a variable has a name. The name of a variable helps us distinguish this variable from all the other variables in the same algorithm. It's not unsimilar to a variable in mathematics. Okay, it's basically a placeholder, and we can just refer to it. Okay, and later on, I can give you some examples. So without a name, it would be kind of hard to specify which variable we need to access. For the time being, variables are visible everywhere within an algorithm. So that means if I use a variable, let's say x, somewhere, it is implied that x is visible anywhere and everywhere in the program. There's no limitation and say that, oh, x can only be seen from this line to this line. No, it's global. Okay, you can see x anywhere within the algorithm. A variable, besides its name, it also has a value. Well, that pretty much is the whole purpose of a variable, is to store a value. Okay? The value of a variable sometimes is also called the state of a variable. In this class, we'll just call it the value of a variable. And then what can we do with a variable? There are 2 things we can do with a variable. The first thing we can do with a variable is to get it. In other words, we refer to the value of the variable. The second thing we can do with it is to set the value of a variable. We can change it, we can update it as a program executes. So up to this point, I know it's all text, it's not very exciting, but let's just kind of use an analogy, and I'll use a similar analogy throughout the semester. A variable is kind of like a coffee mug, okay? So just kind of imagine in your mind, there's a coffee mug, and for those of you who are currently present, let me see if I can find a dry board marker right here. So let's go ahead and think of a coffee mug or a container of whatever kind you want to use. So here's a coffee mug. A coffee mug is kind of like a variable. In other words, how many people have more than one, coffee mugs at home or glasses? Okay. And sometimes you want to use a particular one, or you have a particular one that you're supposed to use, whereas other people in your household has other containers, other cups, other glasses, other coffee mugs that they're supposed to use. So how do you distinguish yours from the other ones? You might have a label. Go ahead. Appearance, okay. But there's a way to ID it. There's a way to identify it or distinguish it from the other ones, right? Okay. Question? No. Okay. So that would be the name of the coffee mug. So in a program, in an algorithm, a lot of times we end up with hundreds or even thousands of variables. So that's why we have a lot of different coffee mugs. It is important to make sure that each one is named uniquely, which means the name of X is unique to this coffee mug. No other coffee mug is named X within the algorithm. And I can name this one Y. Most of the time you want to name the coffee mug according to its purpose, okay? Instead of just a generic name of X, Y, I, J, K, and so on. You kind of want to name them according to the function of the coffee mug. What kind of value is it storing, okay? But in this class, at least at this point, I'll just generically use X and Y, kind of like a mathematical thing to name the coffee mugs. Do we have any questions at this point about the name of a coffee mug? Why we need a name so that we can distinguish a particular coffee mug from all the other coffee mugs that you need access to from time to time? No questions? Okay, so the value of a variable is equivalent to the liquid level or level of liquid in the coffee mug. And that can change over time, okay? So when you wake up in the morning, you get an empty coffee mug from the shelf, right, to put coffee in it. So it starts with an initial state of empty, there's nothing in it. So that's the initial state, okay? At 7 a.m., 6 a.m., the coffee mug has a state of quote unquote empty, there's nothing in it. You make coffee, you put coffee into it, and you fill coffee up to, let's say 90% of the full capacity here, okay? And by doing that, by pouring coffee into the coffee mug, you're changing the value, you're changing the state of the coffee mug, because now the liquid level is now at 90% of its capacity. Are we doing okay so far? The coffee mug itself has not changed, but the value it is storing is changing. So as you drink your coffee, once again the level will change. It will just decrease slowly or quickly, depending on how quickly you can drink hot coffee, right? And at some point you might want to refill it just before you get to school. Okay, you refill it and it goes up again. But you can see that at any particular time, if you use a video camera, to record the liquid level, you can even put a little recorder here, just to look at it, to do a time log of the state of a coffee mug. You can see that it changes over time throughout the entire day. Because when you get home, you might want to drink another cup of coffee, whatever, right? But at any particular time, there's only one state. Am I making that point clear? Okay, at any particular time, it is at one particular level. It's filled up to a certain capacity, a percentage of capacity in the coffee mug. And that's also a property of a variable. At any particular point in the execution of the algorithm, it can only have one particular value. Okay? Are there any questions at this point? No questions? Okay. Another thing is, once you change the state of a coffee mug, it does not remember its previous state. Okay, so let's use the coffee mug example. After you drink the coffee down to maybe half the level here, can you ask the coffee mug and say, well, what was the level 10 minutes ago? Do you think the coffee mug can remember that? Nope. Same thing with a variable. Once you change the state of a variable, it loses its previous states. There's no way to go back in time and say, oh, variable x, do you remember your previous state on this line like a few lines back? It does not remember anything. All right, so are we doing okay so far with the concept of a variable? Now, regarding the two operations that we can do with a variable, okay, the first one is the get operation, referring to the value of a variable. That's kind of like a read operation. In other words, you're looking at the coffee mug and you're just checking the content of the coffee mug. You're just saying, oh, it's half full. Okay, that's it. Okay, you're not changing it. You're just trying to find out the level of liquid in the coffee mug. That's a read operation or get operation. The other one is called a set operation or store operation, update operation, assignment operation. Okay, so all of those things are kind of the same at this point, because what you're doing is you're changing the state of the variable. Okay, let's say the coffee is stale. Okay, you didn't quite finish it on the day, and then the next day you go like, ew, coffee after a day. So you kind of dump it into the sink, and that's a change operation because you're updating the level of liquid in the coffee mug. When you pour fresh coffee back into the coffee mug, once again you're changing it. When you sip coffee, you're changing it. So every time you change the content of the coffee mug, you're updating it. And as a result, in the analogy with a variable, it's the same thing. Every time you change the value of a variable, you're updating it, you're setting it, you're using an assignment statement to update it. Are we still doing okay so far with the general concept of a variable? Okay, so it's good to kind of talk about these terms in general, but let's talk about the specific syntax for an assignment statement. It's just like that. Okay, we have LHS, a left arrow, and RHS. LHS stands for left-hand side, and obviously RHS stands for right-hand side. The operator is a left arrow because it tells you which way information is going. What side is updating which side, okay? So the right-hand side is actually updating the left-hand side. I know we read from left to right, but for some reason, this is how we, this is the syntax of assignment statements of most programming languages. And I think it comes from a root of mathematics where when you define the value of a variable, you say x equals something. So I'm pretty sure that's the root of why the variable getting changed is the left-hand side and not the right-hand side. Okay. So in this particular case, this is called a meta syntax. In other words, obviously not all your variables, or you should not even use this name for one single variable. In other words, if you see something in italic here, it means it's a placeholder. Okay, it is to be replaced by something concrete. So in this case, LHS is simply the name of the placeholder, and in your actual programs, you will have to replace that with the actual name of variables, X, Y, Z, I, J, K, and so on. Same thing for RHS. Now, in fact, RHS can be a lot of different things. RHS, which is the right-hand side, this is the part that provides a value so that you can use that value to update the left-hand side. It's not limited to constants like zeros, ones, and so on. It can also be referring to variables, other variables, or even the variable that you are changing on the left-hand side, which is going to look very confusing because we're updating the very same variable that we are referring to in order to do the calculation. How can that happen? So we'll talk about that in just a moment because I can see the notes down there already. So are there any questions about reading the syntax specification of this kind? You will see this from time to time every time you learn a new syntax, the syntax will be specified by a meta syntax, kind of like this, okay? Because it's a syntax to specify another syntax, and that's why it's called a meta syntax. Any questions? It is very general, very common that they use italic to represent something that is to be replaced by something else. It's just a token. So getting back to the assignment statement. Now, when you see something like this, an assignment statement, and you can clearly tell it is an assignment statement by the left arrow in this case. So when you see an assignment statement like this, there are two steps to perform. Okay, remember there are two steps, two distinct steps to perform. The first step that you have to perform is to evaluate the right-hand side. The right-hand side always gives you a value in the end. It can be a constant, which is pretty obvious what the value is. 0 is 0, 1 is 1, 10 is 10. It can also be referring to a variable, which will be the value of that variable at that time. It can also be an expression, can be a complicated expression. Okay, x plus y to the power of 30, and then the whole thing divided by 10. Okay, can be an expression. But whatever it is, it has to give you a single value in the end. And then what do you do with that value? Well, you take that value and then you use it to update the variable specified on the left-hand side. So those are the two distinct steps. What if the variable on the left-hand side is also appearing on the right-hand side? Do we change these two steps to accommodate that? No, absolutely not. It's still the same boring two steps. Evaluate the right-hand side, update the left-hand side. But that's changing the variable that we were referring to in the first place. That's okay, we are done. Okay, after step 2, you just move on to the next statement. Okay, so now here is a little discussion of why do I use the left arrow symbol? Because for those of you who know any practical programming languages, you know that no actual programming language use the symbol of left arrow, because guess what? It is not on the keyboard. There's no left arrow symbol on the keyboard, okay? But the equal symbol is there. So this paragraph talks about how most, if not all, programming languages do not use a left arrow symbol. And here's a typo here. Rather they use the equal symbol instead. In other words, in C, C++, and most other languages, instead of using LHS, left arrow, RHS, they use LHS, a single equal symbol, RHS, to represent assignment statements. So the question is, well, since I'm trying to prepare you guys for cisp360 and other programming languages, why am I changing that convention and use a left arrow instead? Well, for one simple reason. I do not want to confuse assignment operations with comparison. An assignment operation is an update operation. It's clearly that you have to evaluate the right-hand side, and then you use it to update the left-hand side, which is not the same thing as comparing the left-hand side with the right-hand side and come up with an answer. Are they the same, right? So in mathematics, you encounter, if you're in a math class right now, and you encounter a statement like this, x equals y, what does that mean? Does that mean that we are changing x so it becomes the same as y? What does it mean?
It means they're identical?
It means, well, it can either mean that we know they're identical, x has the same value of y as y, or it can mean, are they the same? Okay, tell me whether it is true or false that x equals y. Okay, in a math class, it can mean one or the other depending on the context. But in a math class, you never update x so that it becomes y. Is that making any sense so far? Okay, but this is a programming class, and in a programming language, that's what the equal symbol means. And you can see that it can be confusing because it's the same symbol, but depending on which class you're taking, it means something that's different. So that means in this case, if you look at this particular line, in a math class, it doesn't make any sense. Because you cannot find a value, x, so that x equals that value plus 1. That just doesn't make any sense. if you present this to a math professor, the math professor would probably chuckle a little bit and then come back and say, well, if you really want me to tell you what this is, I can tell you what it is. It is false. Okay? This condition can never be true for any value of x. Okay? So in a math class, it simply means false, okay? Not true. Because you cannot find a single value of x that can make this true at all. But in a programming class, it has an entirely different meaning. It means take the value of x as it is now, add 1 to it, because we're evaluating the right-hand side. It's an assignment operation. And then use that new value to update x. Okay? In short, we are adding 1 to the existing value of x. Okay? So in the programming class, it has an entirely different meaning compared to a math class. Now, different assignment statements, here are, here's one that is really simple. Okay? So this is pretty much as simple as it gets, because in this particular assignment operation, the right-hand side, which is what we need to evaluate first, is a constant. It's a literal constant, 0. Okay, so that's the value of the right-hand side. We take the value and then we overwrite the variable on the left-hand side. In this case, variable x. So the x now will become 0 after this statement. Are we doing okay so far? It's kind of like dumping all your stale coffee into the sink. Okay, now the coffee mug is empty. Yep.
The 1 means that's just the first line, and then 2 is the second line, right?
Yes, after when we get to that point. Yep.
So the way the computer reads the code is from right to left?
The computer doesn't read the code. The way we read the code is from left to right. Yes. So the convention of reading a program is from left to right on the same line, and then from top to bottom if there are multiple lines. Good questions? All right, so let's go to this slide, this last topic here, getting the value of a variable. Because these operations, or this particular operation, is just setting or updating the value of a variable. You can also refer to the current value of a variable, like in this case. On line 2, we have y gets the value of x plus 1. Now, you have to execute the statements as the way they are ordered. In this case, you have to execute line 1 first, and then you execute line 2. It's called a sequence, okay, because it is sequential. You have to execute the statements in the order they are specified from top to bottom. Are there any questions? Okay. So in this case, what do you think would be the value of y after these 2 lines of code execute?
1.
Yep, ends up with a value of 1, because x, after line 1, x has a value of 0. So by the time we get to line 2, x has a value of 0. 0 plus 1 is the right-hand side of line 2. It gives you a value of 1. And then we use that value of 1 to update the left-hand side, which is y. So that's why after line 2, y ends up with a value of 1. All right. That's very good. That's the first slide right here. Oops. So now it's time to move on to the second slide if there are no questions. So let me just ask, are there any questions about this particular document or the topics that we have just covered? No questions? All right, so let's move on. I was hoping there would be a link to move on to the next topic. That's okay. The next topic is a really, really short one. You can tell from the thumbnail here, it's a really short one. It just talks about sequences, which is something that I mentioned already. If an algorithm has more than one statement, it is important to specify the order in which the statements execute. As far as we are concerned in this class, the computer, or you, because you'll be the one executing the algorithms in this class, you can only execute one statement at a time. There's no parallelism in this particular class. Okay? Is that okay? So when you read a program that is 20,000 lines, you cannot say, I'm going to subcontract these 10,000 lines to someone else, and that person can execute those 10,000 lines in parallel with me. So that doesn't happen in this class. There's no parallelism in this class, no parallel execution in this class. So that means you can only execute one statement at a time. And what a sequence means is you have to execute it in the order specified. A sequence is a list of statements that is specified in a linear order, which means it's one after another. The implicit order is from top to bottom. In other words, if you have a statement on top of the other one, the one on top has to execute first. And algorithms in this class will have line numbers. So in that case, a statement with a smaller or lesser line number execute before statements with larger line numbers. Note that the ordering of statements of some sequences may change the outcome. In other words, if you do not follow the order as specified, you can get a different result. Okay, and that's why it is important to think of the ordering of statements when it is time for you to write your own algorithms. And sometimes just by switching the order by one line can change the outcome of an algorithm significantly. It's not always the case because it depends on whether those lines have dependencies, interdependencies. If they have no interdependencies, then it doesn't matter which order you execute it. But most of the time, okay, they do have some kind of dependency, so you just have to be careful. So don't change the order of a sequence, in this class when you execute it, when you trace it. All right. So at this point, we have covered three important concepts. The first one is the concept of a variable, okay, a place to hold or store a value, and we can also retrieve the value when we need to. So that's the first concept, which is a variable. The second concept we have talked about is an assignment statement. An assignment statement has two sides. The left-hand side specifies what we are changing. It's naming a coffee mug that we're going to change the content. And the right-hand side is providing the value that we use to update the left-hand side. So the ordering of evaluating an assignment statement is always evaluate the right-hand side, come up with a value, use that value to update the left-hand side. So that's the second concept that we talked about. This is the third concept. The third concept is the concept of a sequence. So when you have multiple assignment statements, then you know in which order you have to execute those assignment statements. So those are the three important concepts that we have talked up to this point. Okay? Which means if you look at the homework assignment at this point, on sheet 1 we have the actual algorithm. You should be able to use a piece of paper and keep track of the values of each variable and tell me right after line 4 what would be the value of x and what would be the value of y. Okay? Because you only need those three concepts in order to come up with this answer. Now I don't need you to give me the answer right away, okay, because that really is kind of a part of your homework assignment. But you know what? I don't even really care that much about the final result. I care more about you guys being able to show me what this algorithm is doing on a line-by-line basis. So that's why we have another slide or another document to go over before you can even get started with your homework assignment. The next topic is how do you show me that you know how a particular algorithm is supposed to do. So how do we trace assignment statements? In this case, I have a very simple example. X gets a value of 2, Y gets a value of 3. This is line 1, that's line 2. Okay? So how do we construct a trace in this case? And this document specifies how we construct a trace, at least up to this point. Okay? Later on, there will be more stuff that we will put into a trace. So a trace should have the following columns. Okay? A trace is a table. As a table, a column refers to how you chop it down vertically, and a row is how you chop it horizontally. Am I making any sense so far? Let me just give you an example. If I use LibreOffice Calc, which is a spreadsheet program is really just a huge, the spreadsheet document is really just a huge table. A column is this, okay? A, B, C, D's are columns. Rows are like this, and 1, 2, 3, 4, those are rows. So when you refer to a particular cell, in this case, it is on column B and row 2. Okay, that's how we can identify a single cell in a spreadsheet or in a table by naming the column that it belongs to, and also the row that it belongs to. Are we doing okay so far with the terminology of what is a row and what is a column in the context of a table? Okay. All right. Now that part is kind of important because now we have to kind of think about what is a row and what is a column in the context of a trace. A trace is a table where each row represents a slice of time. In other words, if you think about, okay, what a trace is, it's kind of like a recording. It's like a videotape of how things got changed during the execution of your algorithm. Okay? Think of it as YouTube. Okay, somebody recorded your video clip of how everything got changed and updated during the execution of an algorithm. So in that context, a row is really a frame in the video. Okay? If you look at a single row, you're freezing time in a video recording, and you're saying, okay, what happened right at this particular moment? That's a row in a trace. What a column means in the trace is the historical record of how a particular thing got changed over time. In other words, if you focus on a single column, then you're going to say, oh, this variable started with this value, and then it got changed to this, and it got changed to this, and it got changed to this, and at the very end of the entire algorithm, it ends up with this final value. That's what a column is representing. It is the historical record of a particular thing in your program. Are we doing okay so far? What is a row, which is a slice of time, and what is a column, which is the history of a particular thing. Okay. So at this point, because we have not talked about some of the other things yet, a trace should have the following columns. The leftmost column at this point should be a line number column. And the purpose of the line number column is so that we can annotate the recording of the execution of a program. So we can say, oh, this row is representing the result of executing this line in the algorithm. It's basically kind of like a frame number, but it's not exactly a frame number, okay? When we get to conditional statements and loops, you will see that the line number column is not really redundant because it seems like it's redundant at this point. I'll show you guys examples later. And then for each variable that you have in the algorithm, you also have one column per variable. In this example, how many variables do we have? We have exactly 2 variables, okay, x and y. Now there might be another variable in the algorithm, but since we are not touching it at all, we don't have to document it. All right, so let's move on. This is a lot of stuff, but when you actually see it, it's not really that much stuff. After the labeled row, a special row indicates the initial. Okay, so the columns, they have to start with. See, row here, row 1 is a label for all the columns. So when you look at row 1, column A is my line number column, and I just use line pound or the what is the other way to refer to this symbol? I just call it the pound sign. Is that
Hashtag.
Hashtag number.
Hashtag. Okay. So that's I just use a line number to use this to represent line number. I have one column for X, one column for Y. So you have to tell me which column is corresponding to what. So that's the basically the caption or the label of each column. After the label, I have a column that's kind of weird. It is called the pre-column. The pre-row, which is row 2 of this spreadsheet here, this row here. The pre-row tells me something about, hey, do we have any assumptions of any particular value in the variables? In most cases, we do not. Okay, so unless I tell you, go ahead and assume these values in these variables, you do not make any assumptions. Now, if you don't make any assumptions, and you have a variable, in other words, you have a coffee mug, but I don't tell you what is the actual content in the coffee mug, in that case, you use a question mark to represent the fact that we don't know what it is. Okay? There's a coffee mug here, but before I actually touch it and look at it, I don't know what is the actual content in that coffee mug. So we use a question mark to represent it. And that's a part of the convention that we use in this class. If someone turns in, a homework assignment without the pre-row, or in the pre-row, did not specify question marks for the variables, points will be deducted. Okay, because it is a very important concept. Now, a lot of times, when I talk about the grading standard and stuff like that, some people may think, well, Tag, you're just being, very picky, because, what is the importance or significance of putting a question mark here? It doesn't change anything. Well, I'm doing this just to reinforce the concept that variables, unless you put a value into it, it starts with an unknown value. It has a value, but we don't know what it is. So if you depend on the initial value of a variable without actually setting it first, for the rest of your algorithm, it might do what you think it should do. It may not do what you think it should do. Okay? So that's why it's a very important concept, and that's why I check for it, just to make sure that you guys understand the importance that variables typically start with uninitialized values to begin with. So after this row, which is row 2 in the spreadsheet, we move on to row 3. Row 3 sets 1 in the line number column. That means it is represented. This row is representing the result after we execute line 1. After we execute line 1, let's go back to line 1 here. Line 1 says the right-hand side is 2, the left-hand side is x, so x gets a value of 2, and that's why we have a 2 here. Y is not affected by line 1, so that's why it is retaining its previous value, which is unknown, and that's why the question mark is propagated. On line 2, or right after line 2 executes, line 2 says y gets a value of 3, and that's why y ends up with a value of 3. Well, line 2 doesn't do anything to x. As a variable, x retains its value of 2 from before, and that's why x still has a value of 2, while y gets updated to a value of 3 after line 2 executes. Are we doing okay so far with the format of the trace? And the algorithm only has 2 lines, so that's why we have, a post here. Sorry, I interrupted your question. Go ahead.
Oh, you said say that again on line 4.
On row 4 represents the result after we execute the statement on line 2. Now, because line 2 doesn't do anything to x whatsoever, so x got initialized by line 1 and it had a value of 2, and since we're not doing anything with it, it retains a value of 2. And that's why at the end of line 2, x still has a value of 2. But line 2 does change the value of y, so y got changed from a question mark to 3. Okay. Now, row 5 is also important, even though it doesn't seem very important, okay? It just says post, okay? And by the way, pre represents precondition. It is the condition prior to the execution of the entire algorithm. Post means post condition. It is the condition after we execute the entire algorithm. So line 5 is important because that's the only way I can tell that this is it. This is the entire trace. It's not a half-done trace that you turn in by accident. Okay, you actually intend and say that, okay, this is it. That's the entire algorithm. Now that is important because, yep, go ahead.
Because there's no, we're not really doing anything with x and y after we set them. Is that why the post is blank?
No, post is always blank because post is really just saying, this is the end of the entire trace. It's like, it's kind of like, when
like
you
an end.
Yeah, it's kind of like an end, or in a math class, they use either a square block or QED to say this is the end of a proof. It's the same kind of thing. It's just a marker to end a trace. And but that's part of the convention that we use in this class. Okay. Are there any questions about how to trace an algorithm at this point? If there are no questions, I'm going to do a few examples, just so that I'm sure that we go over the process of doing it. Because the process of doing it, a part of that is really just repeating what I have just said, which is really boring. The other part is how do you use LibreOffice to do it? Okay, so it's a procedural or a tool kind of thing. How do you use the tool to do it? So So I'm going to use LibreOffice. Well, I have it here, and obviously I'm not going to do this one. That's your homework assignment. So I'm going to do something a little bit different. Let's go make a new spreadsheet. All right, so I typically would use sheet 1 here. A spreadsheet document can contain multiple sheets, in other words, multiple tables. I typically would use sheet 1 for the algorithm itself, the algorithm that you're supposed to trace, and then I would use sheet 2 and sometimes additional sheets just for the tracing. Okay, so that's kind of the convention here. So on sheet 1, I can now specify my algorithm. So let's start with something fairly simple. I gets 0, J gets 0, I gets I plus 2, J gets J plus I, and then we'll have just change I to something else. Let's change I to a constant of 5 at the end. Okay, so that's the entire algorithm here. It has exactly 5 lines. Even though I know the row number is exactly the same as the line number, I'm going to do it anyway. The reason why I do this is if you want to print out an algorithm like this, the row number on the left edge of the screen usually doesn't get printed. I mean, you can enable that to be printed, but usually it is not. And that's why I just use a row to kind of duplicate those numbers. And I'm going to add a new sheet here. You can press this little plus sign at the end or at the edge of the tabs to add an additional sheet. So on this particular sheet, I will do my trace. Now I remember line number as a column. I remember I have a variable I, it needs its own column, and a variable J, it needs its own column. So right now I can also change the size of this. You can select the columns by clicking the column header, and then if you double click the edge, once your mouse pointer turns into the double-sided arrow, if you double click it, it will resize the columns to the size that it needs. Okay, so you can make something that's really wide to something just barely what it needs. So this is a precondition. Since I did not tell you anything about the assumption of the value of I and J prior to the execution of the algorithm, they should start with question marks. Okay, so that's kind of the same as your homework assignment up to this point. Are there any questions? Yep.
Do you size it again? Or do you?
I double click when the mouse cursor turns into the double-sided arrow. I just double click it.
I have a question that kind of goes back. What if in the beginning you had I equals J? Would you put down I as
It has to be a
first line?
concrete value. Cannot be just relating I and J. It has to be a concrete value. So you will it has to be I has a value of 10, J has a value of 10, or something like that. But in this case, since I'm not telling you that we should make any assumptions, that's why they start with it. They start with question marks. I'm not answering your question.
No.
Go ahead.
If it's I and then left arrow and then J at the
Okay.
very beginning.
Oh, at the very beginning. So you're
Yeah.
basically saying, what if we try to utilize an initialized value, right? In this
Yeah.
case, what if I change this 0 to a J?
How would you trace that?
You don't, because it is still question mark.
Okay.
It is still question mark, and that usually represents every time if you on the right hand side of an assignment, if any component on the right hand side of an assignment has an unknown value, that's a really bad sign. Okay, that tells you should stop the algorithm right away and say the algorithm has a problem. Because even though we can say it's just a question mark, and since J is a question mark, now I is also a question mark, it doesn't help you understand the outcome of the algorithm. There was another hand up here. Yep.
In the previous example, before you started, you already knew that X was 2 and I think Y was 3.
Nope. I did not. I started with 0. I started with question marks too. Okay, let's go back to the notes here.
Yeah, at the very top.
At the top,
When it shows you the algorithm. There it says X is.
it doesn't say X has a value of 2. It is this is the algorithm that I'm tracing. Prior to line 1, we don't know anything about X or Y. These are the operations that made x equal to 2, y equals to 3 after line 1 and line 2. Okay? So you have to remember, it's not a statement saying x has a value of 2. It is an operation to update x to a value of 2. Yep.
Will we ever know if x or y has a value beforehand or no?
They always have a value. It's just whether do you know the value.
Yeah, that's what I'm asking.
There are, when we get to arrays or some other algorithms, for the convenience of tracing, I will give you the initial condition. So the precondition will have actual values sometimes. Yep. But in this case, since this is more general, in general we don't know the initial values. All right. So those are all good questions. Getting back to the trace here. All right. So let's go ahead and trace this algorithm. Now, you might think at this point, wow, that's kind of inconvenient because we have to switch between, sheet 1, look at the algorithm, switch to sheet 2, do something, and then switch back to sheet 1 and read the algorithm some more. Well, that's why we have this option here. If you go to Window in LibreOffice and click New Window, now we have 2 windows. Oh, there we go. So we have 2 windows. And they are 2 windows into the same document. In other words, I have one single document. It is not saved yet, and that's why it's still untitled 2. But both windows are now referring to the same document. How do I know it's the same document? Well, let's go ahead and make some changes here. Okay, so let's say blah on this side, and you can see blah on the other side. So that means it's really just 2 views of the very same document. Is that okay so far?
What under window did you click again?
I go to the window menu and I click new.
Okay.
Yep, so that will just open up a new window to the same document. Okay, it's a very useful technique because now what I can do is I can have one window to stay on sheet 1 and have the other one to switch to sheet 2. So now I can look at the algorithm on one side and work on the trace on the other side. Okay, are there any questions about this step? Yep.
Can we do it in a way where we just copy this and paste it somewhere in the other document?
I would rather not.
It's gonna save all the history.
Because I can actually see that too, and in prior semesters, I see that and I will basically not give a point to those people until I talk to them because, I see copy and paste and I say, okay, where did you copy and paste it from? And sometimes I can see it's from the same document, which is okay, but other times, if I don't see it, when some people use a separate document to do the trace and then paste it back into the original document, then I would just kind of raise an issue and go like, well, I know this is pasted. Where is it pasted from? All right. So this is.
This one shows you everything, what you do in the document.
Once I start the recording, yep. Shows me all the copy paste, modifications of any kind. Yep. Go ahead.
Attendance?
Attendance. Very good. Okay, let's remember to do it.
If the big no canvas person.
Well, I turn off my my ringer too, so I can't use my phone to remind myself. Okay, this is cisp300 morning section. Okay, go ahead. All right. Okay, so now that we have a mechanism to show both the algorithm and also the trace, we'll just do the trace in place in sheet 2. Okay, that's also what you really should do as well, is to use this technique. Do you think your screen would have enough resolution to do this?
Yeah.
I have this whole thing magnified to 250% of the original size, and I still have room to do it. Yep.
Now, if you close the other window, down this is untitled, will it affect what you have on the first?
Every change that I make to either window is actually made to the same document. In other words, there's only one document right now, and I have 2 views into the same document. It's just a different view to it. Okay. Yep. Go ahead.
Oh, does it matter if it's capital or not?
Oh, okay. That's a good question. Because how do you turn off that stupid auto capitalization and replacement thing? You can go to Tools, go to autocorrect options, and the way I do it is I turn off every single option except to use replacement tables. And I also make one change to the replacement table. which is the lowercase I will not map to uppercase I, because otherwise it will do the auto correction. But you can turn off all of the other ones, at least when you're dealing with this class.
And they'll say for every document in LibreOffice.
Correct. That is a universal or global setting within LibreOffice, within Calc anyway. It does not affect writer, so if you're writing an English paper, then it's a separate setting for that application. All right, so let's go ahead and get started here. So the first line, because I'm reading this program or this algorithm sequentially, I start with line 1. So now I start with line 1 here. So the question is, after line 1, what would be the value of I?
0.
It would be 0, okay. And what would be the value of J?
Question.
Still be a question mark because I didn't do anything with it. And this is line 2. After line 2, what will be the value of I?
0.
0, because we are not changing I at all on line 2. And the value of J is 0. At the end of line 3, what will be the value of I?
2.
Okay, maybe question mark? Nope.
2.
It's 2. Okay. Well, that's kind of confusing, right?
You just substitute the 0 in. That's it.
Correct. Because remember the 2 steps of evaluating an assignment statement, of handling an assignment statement. So let's focus on line 3. I'm going to put the cursor on line 3 here, just so that we know which line we are referring to. So on line 3, it's an assignment statement. It has 2 sides. It has the left-hand side, which is the variable to be updated, and the right-hand side, which is providing the value that I use to update the left-hand side. In this case, the right-hand side is an expression. It is I plus 2. Right now, at this point, what is the value of I?
0.
It's, according to the trace, it has a value of 0. Okay? Is that okay so far? So I has a value of 0. I plus 2 is the same as 0 plus 2. 0 plus 2 has a value of 2. And what am I doing with this value on the right-hand side? I use it to update the value, the variable on the left-hand side. So that's why I on the left-hand side is now updated to a value of 2. But tag is a cyclic kind of thing, because now I is updated and the expression on the right-hand side, is changing too. Well, remember, we perform step 1, evaluate the right-hand side. We perform step 2, change the left-hand side, and then what do? We move on. Okay, we move on. So in this case, it's not quite time to move on yet, because we also have to say, okay, what about J? What is the value of J after line 3? It's still 0. Line J doesn't change J. So we move on to line 4. Okay, after line 4, what would be the value of I?
2.
Okay, and what would be the value of J?
2.
It would be 2 as well, because at the time we evaluate the right-hand side on line 4, J itself has a value of 0. I has a value of 2. So we have 0 plus 2, which is 2. And then we use it to update J. So J ends up with a value of 2 as well in this case. Now we get to line 5. Line 5 says I gets a value of 5. So what would be the value of the cell that I'm highlighting here?
5.
It'll be 5. What about J?
2.
Really?
2? Yeah, because you're not changing anything.
Maybe it should be 7, right?
But you don't.
No, 'cause you don't
Exactly. The relationship is lost, okay? As soon as we're done with line 4, the value of J becomes completely independent of the value of I.
You lost me in 4. Line 4.
On line 4?
Yeah.
Okay. But that's the nice thing about the trace is I can redo it as many times as I want to. And in fact, when you're doing your homework assignment, you can finish it like halfway through, go do something else, 12 hours later, you come back, you know exactly how to continue the trace. That's the nice thing about the trace is it records everything that you need to continue the trace at any time. Okay, so let's move on to line 4 again from line 3. So now we are trying to execute line 4. Line 4 is an assignment statement, which is the only statement that we have talked to up to this point. So it has to be an assignment statement. An assignment statement has 2 sides, the left-hand side and the right-hand side. The left-hand side is specifying what variable we are going to update. we'll deal with that later. The step 1 is to evaluate the right-hand side. The right-hand side of line 4 is j plus I. Is that okay? Okay. What is the value of j at this point? Looking at the trace, j has a value of, what is the latest value of j?
Oh, latest value.
It's always the latest one. Remember, we cannot recall the earlier values. We can only refer to the current value of a variable. It is,
Oh, you just take the result from the last one? Is that what you're saying?
yes.
Oh, okay.
Yes, because a variable can only remember the current value, but not the values before that.
Oh, okay.
So j has a value of
2.
0.
Oh, the I.
Looking at the trace, look at the trace at this point. J has a value of 0. The current value of j is here.
Oh.
It has a value of 0. That's j. I has a value of 2. So
Okay.
j plus I is 0 plus 2, which gives you a value of 2. So that means the entire left-hand side of right-hand side here evaluates to a value of 2.
Okay.
What do we do with 2? We use it to update j. So as a result of line 4, j ends up with a value of 2. Nothing happens to I because an assignment statement can only change one variable at a time. Well, since this one is changing j, that means I gets to retain is whatever value it had before, which is 2. So that's why after line 4, j has a value of 2. Is that okay?
Yep.
Okay. Now we move on to line 5. Just repeat line 5 here. Line 5 has I getting the value of 5, so I is now updated to a value of 5. J is not affected whatsoever, so it has a value of 2. And since line 5 is the last line of the entire algorithm, I just say post, and I'm done. So are there any questions about this particular trace? No questions? All right. Well, if there are no questions about this one, let's move on and have some more examples. Let's do something a little bit more interesting and not as random as this one. Okay, this one's kind of random. So I'm going to close this. I'm not going to save it. If you guys want to kind of reproduce the same thing, for your references, you can always just kind of watch the YouTube and just follow along and create your own document. Okay, so let's go ahead and deal with this one here. It looks kind of funny. Okay, x gets x plus x, x gets x plus x, x gets x plus x. Okay, that's the entire program. And without tracing it, which I will later, can someone kind of guess the, oops, I forgot the last one. I said x plus x, but I wrote x plus 1. Here we go. All right, go ahead.
I have a question. When we do it ourselves, do we have to put the numbers there?
Well, you would need those numbers in order to trace it, because in a trace, you have to indicate this is the outcome of which line of the program executing. You can use the row number as an implied line number if that's what you want. But in this class, for the most part, I write the algorithm and you trace it. Okay. All right. So can anyone kind of guess the outcome of this particular algorithm? Okay. We got a few hands here. So let's go ahead. Go ahead. X equals 8. 12. 8. 8. Okay. Well, this is the thing about the programming class is the correct answer is not by voting. So it's not the the popular vote is not necessarily the right answer, but most of the time it is. Okay. So let's figure out what is going to happen here. If I just kind of go through this in my mind without a trace, I can say after line 2, x ends up with a value of 2. After line 3, x ends up with a value of 4. After line 4, x ends up with a value of 8. So I would suspect that 8 is the correct answer. But since the point of this particular exercise is to show you how to trace it, I'm going to trace it too. Okay. So let's go ahead and go use in sheet 2 for the trace. we have line number, which is a mandatory column because you have to have a column to indicate which line am I executing, which at this point seems kind of redundant because, hey, we're just following it line by line. Why do we even bother with this? Well, later on you'll find out that most programs are not really exactly just from top to bottom. Okay, a lot of times we'll go from one place to another place. Okay, so we start with a precondition, and x is another column representing the value of the variable x. And it starts with an unknown value because I didn't say that you can make any assumptions. So that's the precondition. Here's line 1. After line 1, it's kind of obvious. After line 1, x ends up with a value of 1. So by the time we get to line 2 and evaluate the right-hand side, x has a value of 1. 1 plus 1 is 2. We use that value to update x. So x ends up with a value of 2. By the time we get to line 3, x has a value of 2 already. So when we evaluate the right-hand side on line 3, it becomes 2 plus 2, which is 4. We use that value to update x on line 3, so x ends up with a value of 4. And then by the time we get to line 4, x has a value of 4 to begin with. We evaluate the right-hand side. 4 plus 4 is 8. We use that value to update x on the left-hand side, so x now ends up with a value of 8. And because line 4 is the last line of the entire program, we use post to say we're done with the trace, and there it is. Are there any questions about this particular trace?
Now, if you're gonna create programs like that, when you say jumps to another page, can you go from top to bottom and then back again, depending on the program?
Depending on the control structure, yes. Yep. Go ahead.
So, on the trace, number 3 means that's line 1 on the assignment.
Row 3, yes.
Row three. And
Yeah,
then,
this is the row number. That's
for
the
example,
row number
there was,
3.
There was 10 on row 3. Eventually, you would have 10. You would be talking about 10 on column A on the left side.
Yeah, this 3
For
is the number of the row. It's kind of like an address, so I can find a particular row and column in the spreadsheet itself. This number, on the other hand, is the line number that I'm executing in to be recorded. Are there any questions about your homework assignment? I'm giving you 7 days to do it. And so that means most people will wait until 8 a.m. next week and then scramble and go like, oh, I got a homework assignment to be done, to be due, in an hour, and then do it in 2 minutes, turn it in, right? I mean, don't tell me that's what you're gonna do. I don't want to hear that, but I can actually see from how you turn in the homework assignment when you turn it in, and how long it takes to do it. Yep, go ahead.
Tuesday.
1 week from today, so that will be next Tuesday. It'll be the 11th. Your homework assignment would also indicate the due date too. So if you go to Moodle, if you look at a homework assignment, we're not done yet. We still have 10 more minutes. Okay, so if you go to the homework assignment here, if you click it, you scroll to the bottom here, it will tell you, I mean, I'm looking at it from the professor's perspective, but yours will also indicate when it's due. So this one is due at 9 a.m. right before the class. And some people will be outside with a laptop computer doing it at 8:55, right? It's like, I'm gonna turn in right before the due date. All right, so that is your homework assignment. I'm kind of surprised that nobody has turned it in yet, because sometimes, in prior semesters, I have had people who would do the homework during the class, so by the time I check it again, it's like, wow, there are 6 submissions already. Okay, well, that's, we're moving on from variables, expressions to sequences. Now we are moving on to conditional statements, and I have not had the time to rewrite this particular note yet, so it's going to be using the quote-unquote old format. Okay. Well, with most of my material, I start with why first, okay? In other words, well, we got, what, variables, we have assignment statements, we have sequences, and we even know how to trace those things, okay? So we know, how they execute. Do we need anything else? Well, let's think about, when you're writing an app, okay? Do you think an app needs to do certain things differently depending on conditions? Or do you think it's just a straight line? Do this, do this, do this, do this, do this, do this, and we're done.
Based on conditions. Based on conditions.
Based on a lot of things, right? Anything that requires you to log in automatically has a condition built into it, right? Did you authenticate? Is your password matching or not? Well, if it is, yes, you're in, you're authenticated. If not, nope, you cannot get in. You cannot access the data, okay? So a lot of stuff has conditions depending on something. Sometimes you want to go this route, sometimes you want to go the other route. And with sequences, we cannot do that, okay? A sequence is a straight line, it's a straight road. You can only do it, in the specified order, and you cannot deviate at any point, okay? So that's why we need something that gives us the ability to choose, okay? At one point, you will basically be faced with alternatives. You can say, well, I can go this way, or I can go the other way, okay? But how do you choose which way to go? No, you don't throw a dice. You use a condition, okay? You use a condition to you evaluate a condition. Depending on the result of a condition, you can choose, I want to go this way, or I want to go the other way. And that's a conditional statement, which is the topic of this particular document. All right, so the first part kind of talks about why we use the words true and false instead of the more conventional yes affirmation and no, which is negation. Okay, so in this class we don't use yes no in our programs. Instead, we choose to use true and false when we refer to the outcome of conditions. Okay. And that's a language thing, because different languages have different conventions. So if, in other words, in Chinese at least, the convention is, if I ask my son, have you not eaten dinner today? Okay, so that's the question. Have you not eaten dinner today? And if in fact that he has not eaten dinner yet, the answer is affirmative. Okay, so he would answer yes. Okay, in Chinese the convention is to say yes because it is confirming that my observation was correct. But in English, the answer would be no, right? Have you not eaten lunch today? What do you think? You would say no, I have not eaten lunch, right? So a lot of times you don't repeat the sentence or the question itself, and you simply abbreviate it to no. But in Chinese, it is yes because you are confirming that the statement of the question is correct, okay? And you can see how, but this is convention. There's no particular rule saying which way is correct. It is just, a convention. Most people do it this way, and that's how we understand it, okay, with natural languages. But in programming, we don't want to deal with that sort of thing. We don't want to say, well, some people will look at this algorithm and think it works this way, and other people look at the same algorithm and will think that it works some other way. That would not be good, okay? And that's why we use true, false, okay? Is this condition true? Is this condition false? There's no ambiguation in that case. Okay, so now we want to deal with conditional statements, okay? And before we look at this code here, I'm going to kind of open up a new slide here just so that we cannot see it. Okay, your problem. Okay, I'll give you a problem. The solution is already there. So if you have photographic memory, you can remember the actual solution. So the question is, if I give you two variables, okay, x and y, and I want you to find the maximum of the two variables and store that maximum in a third variable z. How would you do it?
You would compare your first two variables to see
Okay.
which one is larger than the other, and then if you wanted to, I think you said you wanted to store it in value z.
Yep.
And after you compare the two variables, you would take the larger of the two, and you would set that equal to variable z, or set variable z equal to the greater value.
Okay.
X or Y.
Yep. So I like your answer because you use the words that I really want to use. Condition, comparison, and the word if. Okay, so the first thing you want to do is a comparison. Okay, so if you imagine this, I'm going to draw this on the whiteboard too, so people who are just watching the video is not going to get it. The picture is actually in the notes too, but I'm going to draw it on the whiteboard because as I draw it, I can, do the explanation too. So if you think about it, okay, if you think about, an algorithm as a trail, okay, so you're walking down the trail, as you walk down the trail, there are instructions that you have to execute, okay. So you walk down this trail at some point and you say, oh, okay, this part of the trail is responsible to find out what is the larger of the two variables and store it into Z, okay? Well, sometimes X is larger and other times Y is larger. When I design the trail, I have no idea which one is larger because sometimes one is larger and the other one is larger, the other time the other one is larger. So basically what you would do is you will see a sign on the side of the road in the form of a question, a condition, okay? When you see a condition in programming, it is not a statement. It is not saying that X is larger than Y. It is a question asking, is it true or is it false that X is greater than Y? So when you see a symbol like this, you have to remember there's an implicit question mark. It's asking, is it true or is it false that X is greater than Y? Sometimes it is true. If it is true, we go this way. And sometimes it is false. If it's false, we go the other way. So this is a branch, okay? Just like a branch when you are on a hiking trail, sometimes you have a branch and you can proceed one way or the other way. Except in this case, if you go this route, then we'll have one thing to do. This one thing to do is simply to say, well, since by the time we get here, we know that X is the larger one, so we'll just say Z gets the value of X because the intention is to make Z the maximum of the two variables. On the other hand, if you proceed to the false side, then you know by the time you get to this block of code, Y is greater than or equal to X. Okay, they can be the same. I mean, they're the same, that both are the maximum and also the minimum. So in this case, we want Z to get the value of Y because Y is greater than or equal to X. Okay. Now, this is the most important part about a conditional statement. The two paths will join back into one single exit before you get out of the conditional statement. And it does not go back, okay? A conditional statement does not go back. It simply splits into two alternatives, but each path at the end will merge back into a single point before you proceed. Is that making any sense that this code will do what we want it to do? Okay, and it's kind of like a trail map. Okay, it's a trail map. You walk down, you look at the sign, you decide which way to go, and then as you go to each side, you perform the operations specified on each side. Yep.
So what happens to the other block if X is the higher value and we go that way and come to the end? What does the other side do if it merges?
It doesn't. Well, you can only be at one place at a time.
Mm-hmm.
So that means if you, because of the condition, you choose to go to one side, then the other side will not, it's irrelevant for that particular execution.
Sure.
Okay? That's a good question, because you can only be at one place at any time in a trail. So that means if your condition tells you to go this side, then this side is irrelevant. It can specify any code, because it's not going to get executed. You are not executing the code on the other side. All right? So we'll continue this discussion on Thursday. It is likely that you might get a concurrent second homework assignment, using conditions. Yep.
What kind of reading should we have that does not do?
That's a good question. The reading assignment is going to be the conditional statements. Just go ahead and finish conditional statements. That will be good. All right. I'll see you guys on Thursday.